उसको एक नाम दे दे सो दैट यू डोंट फॉरगेट. अभी छोड़ दे
ओके.
उधर जा, सेलेक्ट कर कौन सा डिवाइस
USB डिवाइस. Any hands who are just starting today for their internship?
Multiple hackathons and won them too. So today their session is going to be about NLPs and machine learning.
Everyone, he seems very excited to learn new things. So, Shivansh, can you change the PPT? So, just a simple question: how you guys learn from your past experiences? As a human, when we grow, when we are born, we see different things, we observe different things, we learn different patterns, and we make a decision accordingly. So, we as a human can learn from our past experiences and make a wise decision. But when it comes to machine, what do you think? How they learn? How they learn to make a wise decision? Can you see this object? What is this? Okay. This is a bike and this is a car. Shiva, can he recognize that what it is? Why so? So yeah, that exactly what I meant to say. He can better predict or say that what are these animals, what are their specialty, but he can't say about a car because he didn't got any experience or haven't seen it before in his life. But he is a human being. He can observe and learn. That's true. Every one of us, like, if get through a new experience, we can learn and we can upgrade our knowledge. So our objective is to show him that okay, these are the things, we are living in a world. This is a car, this is a bicycle, and make him learn that okay, yes, now this is a cycle, this is a bicycle, this is a car. So based on the past experiences, he don't know what it is, and being a ML engineer, we will make him learn. So the question is, what about machines? Do they know how to differentiate between car or a bicycle or bike? To perform an arithmetical operation such as addition, division and multiplication, we give some instruction to the machine and they do. But what in part of ML? So how this machine can learn from an image or maybe a text, which we guys are seeing these days, natural language processing. What differentiate between a car and a bike? What? Shape, wheels, gear. Like, as a human we can see and we can say, okay, this is a car, this is a bike. Wheels, gear, length, height, number of doors, that they have doors or not. These are the features which made us realize, okay, this is a car, this is a bike. And if we are able to make machine learn that, okay, these are the patterns of a car, these are the patterns of the bike, these are different features. If it has 2 wheels, it's most probably a bike. If it has 4 wheels, it's a car. And again, the question is like, price in 2025 of any car? How you decide the price of a car? Like when you go to buy a car, how you can know that, okay, what will be the price of this car in 2025 or 2026? Based on your past experiences, based on the size of the car, luxury and different factors which will involve you to predict or decide that, okay, this is the car or this should be, or what it is, what's the price of the car now. So many of you would have seen that facial recognition. As I told you about features, you can differentiate between car and a bike. Same with the human facial stuff as well. You have different features, different person looks different and they are unique in themselves. So what are different features in a person which can differentiate them? Maybe the structure of their eyes, maybe the structure of the face, or maybe anything. So these are the small features which can contribute to find the differences between the two stuff or two persons or two objects. So yeah, we need to provide him experience. So skip. How we provide experience or learning to the model? We have a data set. Data set is what? Collection of data which can give us a specific information, using which we can make this model or machine learn about different patterns, different features, and what it can do with these learning is to get more experience and better predict or classify based on requirement. So when we provide a data, we create a algorithm and execute a program on a data with respect to underlying target task. Again, target task can be to identify whether it is a car or a bike, or to predict the price of a car. Maybe in 2026, what will be the price of this car with these features, where it have this engine, these characteristics, it's a petrol or automatic, whatever it is. These are the various features which will help us to determine, okay, so now we can say this car is going to be very costly for me, or it's very cheap. So again, I just mentioned that. Wait. So based on these data set, the program, which is machine, identify required rules. What you getting with this required rules? Chalo, we'll come to this again. So I hope gave you the overview, like top level overview of what is machine learning, how machine learns, what are different features, and how this machine is trained based on the past experiences to just have a glimpse of newer ideas or what decision points they have to make. So you would have heard of these words: supervised learning, unsupervised learning, reinforcement learning. We as a human being have solved various type of problems in our day-to-day life, and we are very good with mathematics as well. We know that okay, if we are going out, what should be our budget to purchase whatever things we are going to get it. Or if we visually see two things, okay, I like this watch is different. So we have different way or different methods to train ourselves. Imagine you were a child and your father used to say that okay, score good in your examination and you will get a bike, maybe. It's also a way of training. So as we humans are trained, we also train the machines in the similar way. There are three basic ways in which we train a machine. First is supervised learning. Supervised learning, you can see there are levels. That this is a bike. This is specific object belongs to bike, and this specific object belongs to car. We need something called label training data when we are working with supervised learning. Are you clear with label training data? Okay. So whenever we have a training data, our objective is to predict something related to labeled data, which is car here. Here is a function which machine is going to learn from these training data, and its objective is to predict the value car, which is already predefined in our training data set. As you can see here, here are labels and a new sample will be coming. Maybe a bus might be there. So the sample which is coming new will be in the label which is there in the training data. Suppose a truck is there, but the output, what we can see here after the function will always be between car or bike. It won't be going outside the label data which we have. Yeah, sure, you can see this. Classifier or classification, we are classifying different object, and based on the feature we are classifying into one of them. Like see, elephant and tiger, we can easily say that okay, these are elephants because of different features I told you, and this is a tiger. But here the common thing is like both of them have been labeled that okay, the elephant will have these features and tigers will have these features. Is it possible output is a function or continuous real value? It is called regression. Two terms: regression, classification in supervised learning. Supervised learning is the one which we have labeled data. It may happen that we want to predict the value, numerical value of something, some label data, then we call it as a regression. Imagine you have features of room size or area or maybe nearby school or different features which you can analyze that okay, based on these features I can know what will be the price of house in this place. So whenever we go to buy some house or maybe taking a flat on rent in Hyderabad, it's quite expensive. So whenever we go, we see the locality. Okay, it's near this place, it's outside of the city. So based on locality or different feature, we decide okay, this is the price of the house. Based on that, our model, our machine learns with the features. It see the patterns. It find the correlation that okay, the objects which are outside of the city or which have less room, or maybe which is like you have less number of the price is less, and similarly the object which are like far from the in the city and have a very luxury facilities and all will have a higher price. So this problem where our objective is to predict the numerical value is regression, and where we need to classify based on our label data is classification. The classification and regression problem are supervised because the decision depends on characteristic of ground truth label data or values present in the data. So what here it means, ground truth value of labels are, you are seeing car, bike and everything, the label was there, right? That is ground truth. We are telling the machine that okay, learn from these data only, don't go outside of it. Whether I give you truck or maybe a bus, but you have to predict something for car and bike. Again, we have learned about supervised learning where we have these car, bike and levels are there. Other way of learning is unsupervised learning. Suppose just a simple questions. Imagine there is a basket and there are different fruits there, like something with red ball and another fruit is like yellow but bit long, but you don't know what it is. So will you able to classify it, like, or we cluster it or maybe differentiate it or keep it into two different baskets? Why so? Again, because of the same characteristics, same features. Maybe yellow can be a feature or maybe length can be a features. But here you don't know that okay, this is banana or this is apple. But still you are able to do it. This is how we train clustering algorithms, and we train models or machines in unsupervised learning form, in which we don't know the predefined levels. That okay, this is apple, this is banana, and we have to segregate it. The task is to identify that okay, these are the common features between both of them. And these unsupervised learning have lot of applications. You can see whenever you go, suppose a place to buy something, what comes to your mind when I say bread? Jam, butter. Okay, so bread, it comes to our mind butter. Why so? Their combination are like suited, and it's coming to us like with bread it goes butter. Same, these unsupervised learning have a great application in association rule mining, in which if we want to associate a product with another product, which I should recommend you, maybe when you went to a shop and bought something like a bike, I should recommend you, okay, now it's your responsibility, or you should buy helmet, or this user is likely to buy helmet. So here's one more example of unsupervised learning. Seeing the picture, you can say that there is no level of it, that this is red or purple or whatever it is, but based on feature, maybe their position, maybe their color, or maybe their shape, or whatever it is, it got clustered into different 5 features, different 5 objects. So these can be treated at 5 different objects. As I mentioned, if someone is looking for computer, we'll recommend him to view for these stuff as well, because somewhere we know that he's technically inclined, and here how unsupervised learning works. Now it comes reinforcement learning. It seems like the name itself suggests reinforce. We are forcing something to learn. If again, think of you as an agent, an environment is your father, and when you perform bad in your examination or you got failed, then no feedbacks, only punishment. And when you perform good, you got good grades, then it will give you rewards. So it form a pattern. a human tendency is also like to go where to gain for a reward or go for a growth. When we give rewards to a machine, they try to tends to go there. But if they fails or if they underperform, we just take that reward or we just punish it and it comes down. The complete process is known as reinforcement learning. In very layman term, I'm explaining this. You can see and you can just get an idea. So in summary, we learned about what is machine learning, what are different paradigms of machine learning, supervised, unsupervised, reinforcement, and in this lesson we just got an overview like, okay, how we can train machines, what are different ways, like it's just like a human, we have learned that way, and it's just to write some codes and we are able to train a machine to learn on the data set, whether it is labeled, unlabeled data, or whatever it is. Okay. So here you are seeing, we talked about features, right? Wheels, height, weight, color. There are 4 features. And these features will help us to decide that, okay, this is car or this is a bike. Feature sets are collection of all the features which are helpful to identify or differentiate two different label data. Or maybe feature set are set of all features which can helpful to predict some numerical value of the some level data or maybe for any data. For every sample, assign a value corresponding features. So we can see that we assign weights to the features. Weights. If we have feature wheel, height, weight and color, what do you think is the most important feature to in predicting whether it is car or a bike? Wheels. Doors is not there. So wheels is one of a feature like which can be like, okay, this is a feature which can differentiate all of them, and I can say weight as well is a feature which can differentiate all of them. Color, we can say yes or no because car and bike can have same colors. So here you can see these are different wheels, different height and weight and color of the object. We'll go further. When we see these features, individual row, we call it as a feature vectors. And these feature vectors help us to decide that differentiate between two objects or predict something. This form of representation is called vector space model, where all the column names which you can see is features name, and there will be another column which we will call at what is our object, like y value, which we say target value. Again, good features, wheel, height, weight. Bad feature, color, because it won't be effective in all cases or majority of the cases to differentiate between a car or a bike. These are training data set and these are class levels. So when the wheel is 2, what will be the class level? Obviously bike. But how machine will learn it? How machine will know that, okay, it's bike? What is the meaning of this? PR, vehicle type / wheels. Probability? Conditional probability? Like what exactly it does says in English if you say? Yes. So probability of wheel type is something like here we can say what is the probability that it's car when the wheel is already 4? 100 we can see. Change the slide, Shivansh. Okay, so whenever we see a new object comes, when we see that okay probability of wheel type, when already wheel type is 2, what is the probability it's bike? We know it's 100%, and when we see in the car cases it's 0% for here. When the wheel type is 4 and the probability of getting a car, you can see like you can basic probability, you will understand this. So this will predict that okay the classifier says that okay, this is a bike, it's not a car, because the probability of having a 2 wheel is more in case of bike. But what if it was a bus or something? Again, the wheel feature have 4, like bus also, if bus have 4 wheels, so the probability of it will increase and it would have predicted it as a car. Same, we have seen the probabilities, and yeah, again it says the same. Skip. Okay, wait. There is another feature that come into picture, height. Height is greater than or equal to 5, or height is less than 5. So we have categorized it into 2 different ways. Like okay, if a height is greater than 5, we will say it as H or maybe high height, or if it is less than 5, then we will say low height. Let's see how this feature will contribute and tell us that okay, this is a car or a bike. So probability of height greater than 5 and wheel, like number of wheels is 4, of it being a car is 100%. We can see that in all the cases of car, the height is H and wheels is 4. Similarly, we can see here as well. Is there any bike whose height is greater than 5, or maybe the level of height is H and bike wheels are 2? We can say in the data set only it's not there. You can see the wheels, where wheels are 2 and height is H, we can't find anything. So we can say that okay, this is a feature which is also differentiating between bike and a car. Not only the wheels, but maybe height is also a factor which can be considered to decide whether it is a car or a bike. So you just see this and see the data, you will understand it better. So what we have learned so far is how to identify the feature, how to differentiate between different features, how to use different features to decide, okay, this is 2 different things, and how to predict the values of 2 different things, or maybe classify or perform classification on those stuff. But again, when we talk about unsupervised learning, these label data are not there. There is no label. We only see the features and divide it into the 2 different clusters, or maybe number of clusters as required. Okay, we'll move further. So what we were talking about now was a structured data. You know the difference between structured and unstructured data? So, yes? That's one point of the view. Okay, so whenever we say any text, natural language processing, or these days we are using LLMs and a lot of large language models are there. How the machine learns from the normal human text. Before we have seen that, okay, we are giving the training data set in which different features are there, and based on those features, large language machine is able to learn about differentiation, or maybe whatever we want to predict, or whatever it is. So now how machines are learning from natural language? It may be a different language, or different things, or maybe audio or video, or maybe a text or image. So how they are able to learn from those stuff, we'll look into it. So the goals can be very ambitious, like a good quality translation of a text. Like Google is awesome, so does it? The translation isn't good. So how we can improve it, or like what are the basic way of going it? And other NLP goals can be different, as Google is cool. Oh. So another explanation, there was a blunder, like can you go to the previous slide? Next. There was this blunder happened, and you can just read it. Come alive with Pepsi generation. When translated into Chinese meant, Pepsi brings your relative back from dead. So these have been blunders in the past, but now when we see the translation or whatever we see in NLP, things are different. We have reached a level of better way of understanding and translation, not in a translation only, but we have seen different LLMs coming day by day and with different capabilities. So we can see the growth in the field of NLP as well. Have you ever wondered that whenever you write World Cup 2014, like how the auto completion thing happens, like how the next word is being suggested to you? So when you type something like this, the options comes, right? Okay, these are the next word, these are the next word, these are the next word. How it happens? The goals can be to extract the informations. Like you guys might be applying for different jobs at different places, okay? Whenever you upload your resume, all the details of your resume is being extracted and filled into the form structure or something. What do you think, that how it got to know that, okay, this is your name, this is your qualification, or this is your age or work experience or whatever it is, or post or anything? So this is like information extraction when we have large document, or when we have any document and we want to get or extract information and create a proper like manage information of that complete corpus or chunk, which we call as an information extraction. Okay, can you go to the previous slide? So, and the goals can be practical, like domain specific chatbots. How many of you know about chatbots, or how exactly it works, or something? What is domain specific here? So suppose if there is a chatbot which always helps you to know about the finance stuff. Okay, so the domain is very niche. Okay, finance. That you can ask questions, whatever it is, it will reply you like related to finance informations or what. So Shivansh will get you through this about RAG and whatever domain specific things are there. I will just clear out the basics of NLP and build a bridge till there. And again, the goal can be to predict the sentiment of something. Whenever we buy some product from Amazon or maybe from any place, we just do some review or comment. Do you think it's possible to read these many of a comment for a human being and act accordingly? No. We just identify the sentiment of the text. How good they are talking about the product or how bad they are talking about the product. So this process is known as sentiment analysis, where we have a text, audio, video or any data, and we try to analyze the sentiment of it, that positive, negative. It can be a facial expressions as well. Okay, this is a positive facial expression or neutral facial expression, and based on that we decide the business stuff as well. So it's very common in industry. And you would have been using your Gmail, you would have seen that okay, some of the mails directly went to spam section. Why other doesn't go to that section? This is where NLP comes in picture and will help you to analyze, okay, this text seems to be a spam or this text is not harmful. It can be sent to you in your inbox. So okay. नहीं ठीक है. कैसा था भाई?
HTML हटा दिया मैंने. जो भी वैल्यू नहीं आ रहा. लास्ट टाइम स्लाइड इसके बाद हम जो चलेगी. जो भी स्लाइड चलेगी लास्ट डाउनलोड
यही कर देता हूँ. उसके बाद ये करूँगा. हाँ, ये वाला बताऊँगा मैं. रुक जा. पहले ये करना जो भी खुला. गूगल स्लाइड्स
दूसरे अकाउंट में अपलोड किया गया.
अबे वो उसमें ड्राइवर वो चला गया. ये वाला करते ना. खोल दियो. कौन सा लास्ट वाला था ना जो
डेस्कटॉप में बड़ी पावर पॉइंट में खोल लेना.
पावर पॉइंट में वो नहीं है सब्सक्रिप्शन. स्वेचा दिस वन. यहाँ नहीं खुलेगा. Okay, right. So we have seen that okay, natural language processing is there where machine is able to learn about human natural language, what it says. So just remember few terms which I'm just saying here. Corpus. Corpus, document, tokens, vocabulary. So let's go with the first term, tokenization. What is tokenization? Tokenization is a process of segmenting a string of characters into words. What, let's say an example that I'm standing here and I'm teaching NLP. How many words are there? I am standing here, I am teaching NLP. I might be wrong, but still. Let's say 8. There are 8 words. When we do word level tokenization, we will have 8 different tokens. When we do sentence, or maybe if we have different sentences, I am standing there, I am teaching NLP, I am standing here and I am teaching ML. So there are 2 different sentences, and if we do sentence level tokenization, so each sentence will be a tokens. So whenever we see a sentence, we know that okay, here is a full stop, and I know that this sentence has been ended, and this is question mark. So it is a question to us, or maybe the way of asking is like I have to give answer to it. Or but how does models or LLMs or maybe a machine knows okay here the sentence end, or it's quite like how they are learning from the experiences. So these are the classifier which have approaches over there which identify the end of the sentences, that okay whether the sentence is ending or not, and it can be like handwritten rules that okay if in the last of the sentence there is full stop, the sentence is ending, or maybe a regular expression, or maybe a machine learning. How? So whenever a sentence is there, it try to predict that okay next letter or next word is making the complete sentence, is able to make the sentence complete or not. You can just go with this. What is here end of sentence? How decision, the heuristic rules which I told that there can be different rules which can be helpful to identify the end of the sentence. So other important features are like, if I say I told you about tokens, it can be word level or sentence level, whatever, based on our need. But there can be issue like if I say run with R small, U small, and N small, or if I say R capital, U capital, N capital, the meaning of both of run is same. It's run. But does machine knows this? That no, it's same. So it create lot of unwanted tokens which create again sparsity, and it's not good practice. So we just before going with the NLP task, we just clean and go through a process. So we make the text or sentence or a natural language into a format which optimize our resources and also help machine to learn better. Okay, so these were talking about different algorithms which can be there, or decision tree, naive Bayes. Okay, so let's go one by one. What are the different process which can be there? Word token, an occurrence of word. For the above sentences there are 11 word tokens. You can see a sentence, I have a can opener but I can't open these cans. Word type, for the above sentences 10 different word types. There are 10 different unique words which are there to form this sentence, a meaningful sentence. Okay. There are tools in Python, NLTK libraries there you can use, or I think most of us are from Python, so you can explore like Java, Stanford, Core NLP there. These libraries, what I told you about segregation of the words like tokens. So these libraries are helpful to get these tokens or getting the proper way. So these are the examples. There are different languages, and in English the tokenization can be different, and there can be different tokens for different languages. So it's just how we are deciding the tokens at what level. We'll show you. So it's again word segmentation. Go to the previous slide. No. Text normalization. So moving further, let's see what is text normalization. As told that will reduce all letters to lowercase. Why? We'll have a less token and it won't confuse between run with R capital and run with R small. Uppercase and mild sentences may point to named entity. Example, General Motors. Or empty in information extraction, some cases might be helpful, like US versus us. So case folding is reduce all letter to lower case to keep it equal and like better go with this. So what is lemmatization? We'll explain you. What is the difference between running and run? But both of them means the same, right? That someone is running, or it's like when we want to teach machine that okay, run and running are two things. So when we don't treat each word and bring it to the base form, we end up getting a matrix with lot of zeros and ones where it becomes very sparse and it's not a good practice. So what we do in lemmatization is to bring the word to the base form. Playing, play, running, run, eating, eat, eated, eat. So different tenses are there but the meaning of and the sense of the word is same, is to run or eat or play. And stems is the core meaning behind bearing units. Again, run, running. So the core meaning is to run. We deal with this prefix and suffix as well, that okay, uni, anti, so which helps us to get a word core meanings as well. And yes, the difference between lemmatization and stemming. Stemming does the same, like bring the word to the base form, but in stemming it's not necessarily a dictionary word. But in lemmatization, whatever the base form word will be there will make some sense or maybe there in an English dictionary. Okay, so this is same continuation with the more examples. Automate, automatic, automation, all reduced to automate. Here you can see automate, no words like automate exist. But if it were a lemmatization, it would have automate or something, where a clear meaning will be there. So there are many algorithms, again analytical library which I told, help us to know about various, use various algorithm and do this systeming and lemmatization at very easy way. So you can skip the algorithm part, this one. It's not needed, I guess. So we have seen that, okay, these are the words, these are the tokens. How a particular sentence differs from the different sentence, or maybe how we can find the relation, or we can use how two words are related, what is vector. So just see, you can go and try yourself as well. If you see the word funny there and observe the vector space, you can find the nearest point in the original space, that is humor, with a score of 0.832. You know about vector space, right? Numerical representation of this word funny will be a vector. So nowadays what LLMs we are having, there are different, whenever you are sending a text, any text, it's converted into numbers, and how these numbers are decided, these come from various algorithms. There are, and like Google realized, okay, so let's bring some algorithm which can convert the words into a numerical patterns, which we can use cosine similarities or different distance metrics to find the relation of it was. So if we type there, instead of funny, something like sad. Wait, I will show you. So you can see, as soon as I gave the word sad, a different set of words are there which share somewhere the similar information or similar sense. Disadvantage, crusades, sad dam, whatever it is. So Google bring out with a model that, okay, there are different vectors, different tokens or different words. How we can find the relation between them? What the sense of one word can impact the others, or if they two words are together, what is the meaning of it? So later these approaches, we went through embeddings, how vector embeddings have been created, which we will cover later, and how the LLMs understand about different words and meanings and correlation and everything. So we'll go through one small code just to show you that why these vectors are very important. So as mentioned, these are the libraries which are very important when you are working in field of NLP, NLTK, GenSim and Spacey. This line of code will download the library, and as I mentioned that Is it clear now? Okay. So by representing words in a vector, we can use linear algebra or vector space model to analyze the relationship between them. Let's say one simple task is to calculate the cosine of two words vector. As I mentioned that words are represented in form of vector and in numbers, you can say, and based on these numbers, when we find cosine similarity, maybe by a dot product, then we can decide that how two vectors are similar. You can see here the word name cat, dog, car, and here is the vector representation of these words. And from where these vector representation is coming is through this model, pre-trained model, which is there, made by Google, I guess. And now we have this vectors, we can find a similarity with another vector. So here you can see the cosine similarity of the cat with cat, which is 1. And what is the cosine similarity of cat with dog? It's 0.8. Why these two words are having more cosine similarities or less cosine similarities depends that how these two are more related. So when we talk in numbers or in vector form, it's very easy for us to analyze and get a better understanding of the word by their relation. Okay, so just a question for you guys. What do you think? Here is a word, man minus, where is that? Wait. Okay, so here is a word, king, and another word is there, men and woman. The result I want is like king minus men plus woman. What do you think should be the result? King minus men plus woman. Yes. So if we perform this vector operation, king minus men plus woman will get a result as queen or she, who. So these were the results of what we have tried, like king minus men plus woman. So I think I have given you the basic understanding of what are vectors and why these numbers are important. That okay, so if we represent a data, a word in a vector format, we can find the relation with the other words as well. We can change we can get complete understanding similarities, and we can do lot of operations with that. Moving further, I want my friend Shivansh to continue with other part in it.
स्लाइड खोल दी इसमें आप।
क्या मैं इसमें खोल दूँ?
इसमें खोल दी मैंने। इसको स्लाइड शो पे कर ले।
कनेक्ट तो करो।
Is there any hands-on in modeling this?
Yeah.
Yes.
Right now?
Yeah, it's coming up.
Like
Mic also. Shift. नहीं
guys are aware of ChatGPT. So you would have seen that recently ChatGPT rolled out a feature where you can upload different types of files and interact with them, right? So you can upload your PDFs, your documents, your audio files, video files, any sort of multimedia, which can then be utilized or sort of given as a context to the chatbot, based on which you can ask questions, right? So that is a bit similar to what we're going to do here today. So in a while, I'll share my code repository with you guys, where you can upload a document, and based on that document, you can chat with an LLM and ask questions based on that context. But in order to do that, we need to go over a couple of simple concepts regarding how this actually works. So the way this works is by the technique of RAG. So RAG means Retrieval Augmented Generation. So let's break it down word by word. What is retrieval? Fetching something, correct? So what retrieval in this context means is that we're going to retrieve the relevant information to the user query. So let's say you have a document which details about animals and plants, okay? Now you put up a question to the chatbot that what does a lion do, for example. So you want to retrieve the accurate part of the document in order to tell the chatbot that, okay, use this part of the document to answer my query. So that is what we call the retrieval part. Now, I'm sure that you guys know that each LLM has a knowledge cutoff. So let's say, for example, for ChatGPT 4.0, the current knowledge cutoff is July 2022. So basically, any data that came after July 2022, the chatbot would have no context. So let's say the recent Indian-Pakistan conflict, it would have no information about that. So what we are doing in RAG is we are augmenting the response of a chatbot by providing it the latest context. So this can have multiple applications. For example, updating the knowledge of an LLM. As I mentioned, you can maybe provide it with documents of current affairs and ask questions based on recent conflicts. Second can be specific personal data. So let's say you have a project report coming on, okay? So you managed to get hold of some general project that was out there and you want to ask questions regarding that. You want to dive deeper into the concepts that are mentioned in that report. So what you can do is you can apply RAG on that report, and based on that, you can ask chatbot some questions. So the way this works is that we take the document and we chunk it into very small parts. Because let's say we have a 100-page document. Okay, we cannot give that 100-page document to the chatbot and expect it to answer our query. So we chunk it and we store it in a database. The way we do this is we convert them into something called embeddings. So as Divyanshu explained, each text when we are creating a data set, we have multiple features, right? Like in the case of car, we saw that there's wheel, color, weight. So let's say these are the three features, right? And we assign a numerical value to them. So let's say there's car 1, which has the value 0, 1, 2. There's car 2, which has the value 2, 3, 4. So these are what we call vector embeddings, essentially. So these numbers can now be used to represent these objects, right? So we just went from text to numerical using these vector embeddings. So the way this is done in the GenAI domain is through something called as vector embedding models. The sole purpose of these models is to convert your text, documents, images, or whatever might the data be into huge vectors. Now, like in the case of car, we saw that the dimension of this vector was 3, right? There were 3 features, so 3. But since we need high precision in this field, we use embeddings which are, let's say, 8,000 dimension vectors. So this improves the precision of how fast we'll be able to fetch them when needed. So we take the documents, we take the images, audios, whatever the multimedia data might be, we put them through an embedding model, and then we get these vectors. Now you can easily represent these vectors on a multi-dimensional graph space. So let's say I'm taking a vector of 8,000 dimensions. Then I need a graph which can store these details, right? So if simplified, imagine like a normal 2D graph, you have X and Y component. So for each text, you'll have a value of X, you'll have a value of Y. You can simply plot that on a graph. Now imagine this if we had 8,000 dimensions, how accurate that representation would be. So now I'll explain a bit on how these vector databases work. So you guys are aware of normal SQL type databases, right? Structured data. So this is a slightly different to that. In that, you're essentially storing the data in tables, but here we store the data in graphs. So each input becomes a point on this graph. So let's say if shift a focus towards the top path where we're ingesting the data into a vector database. So we have our embedding model which will give us the vectors. Second, we have the data that we want to convert into embeddings. So third, now we push the data to the embedding model and we have the vectors and the metadata. Metadata is nothing but a small description about the data. So it can be something like name of the file, for example, the size of that file, right? Then we put this through an indexer. What this indexing will basically do is it will create that point on the graph which can then be saved into the database. I hope this is clear. Any questions, anything that you might not have understood? Anyone? Alright, let's move forward then. So now I have points on my graph representing specific chunks of document. Okay, so let's say I have 5 chunks of a document. I have stored them into multiple points on a graph that is stored into my database. Now next, let's say the user comes in with a query. Now I need to find that which of these chunks will be relevant, right? So what I'll do is I'll convert the query into a vector, similar to what I did with those chunks. So now I have a 6th point on the graph. Now what I can do is I can find out that what are the nearest points to this one, right? So let's say that red point, if you see in the bottom image, let's say the red point is my query. So I can find out that what are the nearest chunks which might be relevant to this point. So based on that, I can fetch some chunks out of those documents. So maybe like, let's say I had 5 chunks in total. I find out that 2 of the chunks are very near to my query point. I'll fetch those and convert them back to text. So now, based on the query, I have relevant chunks of the document which the chatbot can then use to answer my query. So this is whole of how the RAG works. Okay, so in order to summarize, this is our whole workflow. First, we take the raw data, right? Then we extract the information out of it. So let's say we have the PDF document. So we'll convert PDF to normal text document. If it's a docx file, then also in that case, we'll convert it into a .txt file format. So that's what we mean by information retrieval. Then we'll chunk these documents into smaller parts so that they're easier to ingest into our database. Then we'll run these chunks through an embedding model, store them in a vector database. Now, when a query comes, we're going to call the same embedding model and hit the vector database with that point to find out that what are the nearest chunks of data that might be relevant to this query. Then, based on relevant data, we'll call the LLM and get you a response. So this is what we're going to implement here today, and I think this is what your assignment is going to be for today's session. Is that correct? Okay, so she'll brief you about that later. So if you want to follow along, this is the QR code for the Git repository that I'm going to be sharing today. Keep that as a reference and not as, a default way to get through this assignment. जा वहीं बैठ जा. नहीं चल रहा. Okay, so can you guys see the screen? What's written? Is it visible to everyone? Visible? At the back? It's visible? Okay, so let's move forward. So,
Can you screen share your thing in a meet?
yeah, sure.
I'll see the code.
Just a moment, guys.
Is this on mute or like
It's live? Okay. Okay, so you guys have a very basic understanding of how Python scripts work. Am I correct in that? Okay. So we'll start with what libraries we're going to use for this project. I hope the project outline is clear to you guys, that what we're about to implement. Okay, I see a lot of blank faces. I'll reiterate on what I have explained. So basically, our application will have two pages. On the first page, we'll upload a document which will then be ingested into our vector database. And then in the second part, we'll have a chatbot which can answer your queries based on that document. So I'll show you how that actually looks. Give me 1 minute. Okay, so as you guys might be aware that we cannot run a front-end script in Python, right? So Python is a back-end coding language in which you write the core logic, which is then served by a front-end such as maybe React.js or any JavaScript front-end, right? Which runs in your browser. But there's a library named Streamlit which helps you build front-end through your Python scripts. So that is what we're going to be utilizing today. So this is how your application is going to look like at the end of the day. So as you can see that we have the option to upload our document. So let me give you an example of that. So here I am ingesting this extracted text. So these are the top 20 international news of June 2025. So there's no way that our LLM would have any context regarding these news since it has a knowledge cutoff, as I explained before. But now that you'll see that I'll be able to ask the chatbot questions based on this document. So let's say, let me pick this one. So we have just ingested this into a vector database. Now if I go to the chatbot and ask about so here we have the answer and here is the relevant fetched context from the database. So it picked up that, okay, we are talking about this specific conflict on which it should gather some data from the vector database. So it was able to easily answer my query even though it had no clue that, okay, this document exists, just because we are employing the RAG technique. So this is our agenda for today. This is what we're going to build. Okay, so a couple of things I'll run over quickly. So first is a virtual environment. So as you know that we install packages into Python using pip install command. Are you guys aware of that? Right? So one good practice that you should all follow is to never install the packages into a global environment. So let's say if I fire up my console and I write something like pip install Streamlit, then that will install it in a global environment. This might cause issues for your other projects. So what we always do is we create a small local environment for which will be specific to this project, and we'll utilize that environment to run everything. We'll install packages into that, we'll run our scripts into that. So we won't be utilizing the global environment, we'll use something which is more specific to our project. So in order to do that, we need to write a command which goes like python -m. Now -m stands for module. So it means that we're going to employ a default Python module to create this environment. So the package name is venv. So venv stands for virtual environment. So we're going to utilize this module and we're going to create a virtual environment named .venv. So this is an industry practice that whenever a virtual environment is created in Python, we use .venv.
The screen sharing.
I stopped the screen sharing. 1 minute.
Connection error. Entire screen.
Shall I start?
Yes.
Yeah.
Okay. 10 minutes.
It's working.
Okay. Okay. So using this command, we're going to create a virtual environment. I'm not going to run this because as you can see here, I already have a virtual environment. So once this executes, you'll see this folder pop up. Now what we need to do is we need to activate this virtual environment. So for your ease, I have already placed a script which you can directly execute. So if I go into my terminal and write activate, it will run this hidden command. So I can just copy it and run it.
Virtual environment.
TVNBs. Okay, so as you can see, it's written here that what is my current environment. So you can see .venv written here. Okay, great. So now I'll start by installing the required packages into this environment. In order to do that, I have a requirements.txt file which outlines which packages I'm going to be needing. So first is Streamlit. This will be used for the UI components that you just saw on the web. Second is OpenAI. So we'll use the OpenAI package to actually call the LLM. Third is tick token. As I mentioned that we'll be chunking the documents, right? So that is what the tick token library accomplishes. If I give it a document and I tell it that, okay, these are the rules for chunking, it will give me a list of text-based chunks, which I can then ingest into the database. Then ChromaDB. ChromaDB is the vector database that we're going to use today. So if you see, there are a lot of databases available in the market, which you can utilize. You have PG Vector, you have Pinecone, you have Qdrant, but the easiest one to use is ChromaDB. So if you're having a small project that you want to utilize, you can use ChromaDB. Then third is Markdown. If you remember from the graph that I showed you earlier, there was a stage called information retrieval, where we essentially convert our documents, our PDFs, our presentations into simple text. So this is what this library is for. It is built by Microsoft. So if you give it a document, it will convert it into normal text without using any heavy model. Just using your CPU processor, it can do that. So these are the packages that you're going to be needing for this project. So in order to install all of these at once, the command is pip install -r. So -r means recursive. So if I employ a -r flag, it will go over line by line of this requirements.txt file and install all the packages. And then I just say requirements.txt. So what this command will do is, it will open this file, go over package by package and install it into my virtual environment. I have already done that, so it takes a bit of time to actually install these packages since they are a bit heavy on dependencies. So now now that our virtual environment is ready with the packages, we can now start our scripts and we can start coding. So we'll start with the main.py. So this is where our main Streamlit logic resides. So first we import our Streamlit, then we set some basic page configuration. So we can give the page title and how the layout is going to look. So this, if there are any front-end developers here, they'll know that there are multiple layouts available to view inside Chrome. So one of them is white. So as I mentioned that we are going to have two pages. One is to ingest the document and second is a chatbot page to interact with it. So this is how we are going to declare that where our code for those pages reside. So if you see in my directory here, I have a folder named pages which has two files inside it representing each page. So Inside Streamlit, we have a dot page function using which we can initialize these pages and also give a title to them. Next, we need to attach these two pages onto our main running stream. So how we do that? We give it a list in st.navigation. If it's a bit hazy on how Streamlit works, you can always refer to their documents. So if you go and type Streamlit docs, go to the Streamlit documentation page. Under develop, you'll find the API reference section. So here they have mentioned all the widgets and how you can build your own Streamlit application. So I am going to be explaining a bit more the logical part rather than explaining how Streamlit works and how these components have been created. So you can go over these documentations. It's very easy to understand. I'll give you a small example on how you can utilize this. So we were on pages, right? So if I go to navigation and pages section and click on st.page, you can see that it's mentioned how I can utilize this function. What are the parameters going to be? So let's say I was using the page parameter. Here I have mentioned the Python file which needs to be run for that page. You can also find some basic snippets. So you'll find that this is a bit similar to what we have here. We have the two pages defined here. Then in st.navigation, we are attaching these pages and then we are using pg.run. So you see it's awfully similar to what we have in the documentation. So it's very easy to follow along. Just go through these documentation once. Okay, so now inside the pages folder, this is all it requires to create a chatbot. Okay, so we give a title to this page. Okay, then we give it a heading that you can ask your questions about your ingested document. So if I have the Streamlit running, okay, so you can see that this is how it will look. So we gave the RAG Q&A chatbot heading and we wrote that, okay, this is what I want to show to the user. Then we'll take a query from the user. Now this can be done through chat_input. So you saw your question is written here and a placeholder for entering user message has been created. Next, once we have this user query, we'll run this function which will query our RAG database and fetch us the context chunks, right? Now, we'll give these chunks to our LLM, which will have the user query and these context as input, and it will provide us with an answer. This answer will show it back to the user using the markdown class, and we'll also show that, okay, this is what we have retrieved from the database based on your query. So you saw here that we were able to actually retrieve the chunk based on which our LLM has answered the question. Any doubts, anything you didn't understand, anything you guys want me to go over? Okay, let's move forward then. Now the ingest page. So in ingest page, we'll have an upload section where we're asking the user to upload a file. That can be done using the file uploader function, where we give it some text to show to the user and we define what type of documents are accepted. So right now we're supporting TXT, PDF, MD, HTML and docx formats. Once the file is uploaded, we're going to save it temporarily using this into our local directory. Then we'll use Microsoft's Markdown to convert it into simple text. Now this text will be shown to the user as a confirmation that, okay, this is what we have extracted out of the document. So the information retrieval phase. Then we'll summarize the document for the user so that he has a better grasp of what he has given as input. I'll go over all of these functions like chunk text, ingest documents, where they're coming from, how they're defined. So that is the core logic of the application. So when we call the chunk text function with this document text, we'll get a list of chunks. So if you hover over this, you can see that the expected return type is a list of string. So you guys understand what lists and strings are, correct? Okay. So now we'll call this ingest documents function, which will hit our ChromaDB server with the embeddings for these chunks. So it accepts all these documents and uses ChromaDB to ingest these documents into a vector database. Then we'll give the option to switch to the chatbot page. So this is the definition. This is how the UI has been built for this application. This is where we're defining all the functions and calling them simultaneously. Now we'll go over the core logic of the application that refers to how the documents are chunked, how they are uploaded into the DB, how they are fetched, how the LLM are called. So I have broken down the logic into two files, that is Chroma services and GenAI services. So Chroma services will deal with everything that has to do with the database, and the GenAI services will refer to all the code that has gone into calling the LLM and chunking the documents. So let's go over Chroma services first. Okay. So one more common practice as a Python developer is to never store secret variables in your code. So these secret variables can be your API key, which if stolen could be very catastrophic. So it's better to use something called .env package. What this .env package does is you store all your environment variables in a separate file marked by .env. So right now if you see on the screen that we have a .env template file where we are defining that where our model is hosted. So this is currently hosted on Google servers, the model that we're going to utilize today. This is where you put your model key. So this key is given to you by Google and they bill you based on that. So right now what we're using is a free model. So you can all go and register for this API key. It is a very good model. It's called Gemini 2.0 Flash. And thirdly, a collection name. So as I mentioned that in vector databases, we have a graph. So this is essentially the name of that graph, since you might have multiple graphs for the same project. So now how we read this environment file is through .env. So we say that okay, load the .env and this is the path for that env file. So this is the env file that I have, which has my API key and the model name that I'm going to be utilizing. You can take context from the template.env and create your own. Now whenever I want to use any variable from this environment file, I will use the OS library and say that get this environment variable and pass in the variable name. So this much is clear to you guys? You guys have a context on how environment variable works and why we keep them separate from our code files? Okay. So the first function that we're going to deal with is ingest documents. So if you remember from the previous explanation, this is the function which takes a list of document chunks and uploads them to the Chroma database. So first of all, we need an ID for individual chunk. We accomplish this by using a for loop. So we say that for every item inside my list, we'll calculate a number for it and assign it as chunk 0, chunk 1, chunk 2. So that is what this line accomplishes. It will give me a list of IDs. So let's say I give it 9 chunks. So mapped to these IDs variable will be a list which will go from 0 to 9. Is that clear? So the length of the list IDs will be similar to the length of the list docs. So docs has my actual data and IDs just has a name, chunk 0, chunk 1 and so on and so forth. Now, in order to add this to the ChromaDB database, we need to initialize the Chroma client. The way we do this is we import ChromaDB as a package. We initialize the persistent client. Now, the meaning of persistent client means that even if you shut down the server, the data inside this database will still persist. Persist as in it will still stay in that directory. So when you boot up the application again, you won't lose any data. In order to do that, we give it a path onto where it can create a folder to save these files. So when I run this script, you will see that a folder pops up named chroma_db. This is where all our vectors will be stored. This is where the graph will be built. Next, as mentioned, we'll name this graph something. So we'll create, so that graph is called a collection. So it is a collection of vectors which we call a graph, right? So we'll get or create collection. This function will ensure that the collection is created, and if the collection already exists, it will pick up the same one rather than creating a new one. So one of the best techniques as software engineers that you can employ is to hover over the function that you are utilizing. So if I keep my mouse here, you will see that it will give me a definition of exactly what that function does. So reading this will give you a lot more context than any YouTube video will ever give, right? So this is just a tip. Next on, now we're going to utilize this collection to send our documents to this database. So all we need to do is call the add function, give it the documents that we want to process and the IDs that we have assigned to each chunk. So that is all it takes to insert my my chunks, convert them into vectors and store them into the graph. Next, now that I have data into the database, now how do I query it with my user's query? So I need to take the user query and find the relevant chunks, correct? So this function accomplishes that using the query function of ChromaDB collection. What we'll give it as input is the query given by the user. So if you see in the function definition, we have two parameters. One is the query text, which is the string we are searching for, and the number of results to return. If you remember from the previous graph, 1 minute. So here, once we converted our query into this red dot, we fetched some number of points that were in the neighborhood of that, correct? So as we can see in these green dots, there are 6 points. So I need to tell my database that how many chunks do I want to retrieve for this query. So that is represented by n_results variable, which says that okay, these are how many neighborhood points I want to fetch for my query. Now we'll give this to the dot query function, we'll give it the query text and the number of results we want to return, and with this result we can return that okay, these are the relevant chunks that have been fetched with regards to my document and the user's query. So that is how we are going to utilize the vector database to first ingest the documents and second retrieve the relevant chunks. Next, our GenAI service. So this is where the magic happens. This is our core logic of the application where we're calling the LLM, we're giving it these chunks and we're actually getting a response. So just like we initialized the ChromaDB, we need to initialize the OpenAI client. You guys know about OpenAI? You know what it is? Alright then. So we'll initialize the OpenAI client from our environment variables, models, API key and the base URL. So a quick reference to the environment file, we have these variables here which have our API key and the base URL which suggests that where our model is hosted. Once this OpenAI client is initialized, we can utilize this to gain a response from it. Now, the way that the OpenAI client works is that we call this function for chat completions. So what chat completions essentially mean is that you tell it that okay, this is the message from the user, and based on that, OpenAI will give you a response from the chatbot's side. So the parameters that we need for it is which model you want to call. So as you guys might be aware that OpenAI has multiple hosted models. We have GPT-4o, GPT-4o mini, O4 mini, O3 mini and so on and so forth. So we need to tell it that okay, this is the specific model that we want to utilize, and it will pick this up again from our environment variables. So right now it is set to Gemini 2.0 Flash. So this is a model by Google hosted using OpenAI spec. Once this function can be used to relay the user messages to the OpenAI service and gain a response from it. Now we'll use this function for first summarizing the document and second to get the chatbot response. Now we'll look over the summarize text function. So this is how the OpenAI API expects us to structure our messages. So messages will be a list of dictionaries where each dictionary will have two keys. One is the role, second is content. There are currently three roles that are supported by OpenAI. First is system, second is user, third is assistant. So we provided with system message and a user message, and OpenAI will respond with assistant type messages. So we give the content. So this, if we look at this dictionary, this basically says that this is my system prompt. These are the instructions I am giving to my chatbot module. And here it basically says that, okay, this is what the user is telling me. This is my user's query. Okay. So if we see in the first part, we have a very basic prompt which says that you are a helpful assistant that summarizes documents accurately and concisely. In the second part, we are giving it the user query which says that please summarize the following text concisely with capturing the key points. So if you see, I have used the letter F here. Does anyone of you know why this is used? Yeah, so this is a formatted string. What a formatted string means is that there will be a variable in the middle of the string which must be replaced in future in order to get the final string. So here it is text. So this is where we'll give the text of our document as input, and then we'll ask OpenAI to summarize it. Now with this messages list intact, we'll send this to our call LLM function which we went over earlier. Now this function will return a response from the OpenAI model. Now in order to chunk text, so when like we went over the requirements.txt, I told you guys that tick token is the library we're going to be using to chunk our documents. So this is the implementation of that. So what we need to do is we need to tell it that where we're going to feed these chunks into. So we are going to feed this into OpenAI, correct? So what it uses is a GPT 3.5 turbo embedding model. Now you don't need to go into very details of it right now. So for now you can just assume that we're telling it, okay, our chunks should be compatible with OpenAI models. So that is essentially what this line means. Now with this encoder initialized, we'll call the encode function and give it the text we want to convert into vector embedding, into smaller chunks. Now these tokens will have those chunks for us. Based on the length of the chunks, there are some small operations that we need to go into. So if you see in the input parameters, we have the chunk size. So this will determine that how many words or tokens should be there inside each chunk, inside each chunk, and how many of the words should overlap. Okay, so basically if I have two simultaneous chunks side by side, then they'll have 10 intercepting words. So these 10 words will overlap in both of them. Now our answer with context function. What this function takes in is the user's question and the relevant chunk fetched from our Chroma database. As you can see, we have two arguments, user question and list of relevant document chunks from our ChromaDB instance. Now what we'll do is, since this context is a list of string, we need to convert this into a normal string. Since OpenAI gives us a LLM based model, it cannot understand a list, it can only understand a string. So we use the join function in Python to combine this list into a single string. Now this combined context will become a part of our messages. The first message is the system message which dictates our motive and what the chatbot should respond with. So we say that you are a helpful assistant that answers the questions based on the provided context. If you don't know the answer based on the context, say so. So this will give us a more transparency with the model where you guys know what hallucination is? Okay, so a side detour, hallucination is when a model cannot respond to your query, so it gives you some gibberish. Okay, so let's go back to our simple example of animal and plants. So let's say the OpenAI model only knows about plants and doesn't know about animals. Now you go to OpenAI and you ask some question about animals. Now it doesn't have any clue that what are animals. So it will pick something from its plants knowledge base and will give you some response which is related to plants. That is not what we want, right? So this is what we call hallucinations. So the model hallucinated and forgot that what the question was and what it needed to answer. So in order to curb hallucination, we instruct the model that if you don't know something, then say that I don't know rather than giving some gibberish output. Now in the user field, we'll tell it that okay, this is the information that you have to answer my query and the query itself. So we have already declared these variables, combined context and question. Now again, we'll simply call the OpenAI LLM, give it these list of messages and extract a response from it. So these are the core functionalities that are being served using this Streamlit application. So just an overview of how the functions that we've just went over have been used. In the chatbot page, we're using the query documents to extract list of chunks that are relevant to us. Then we call the answer with context function, which will give us a response from the LLM model. In ingest page, we use the summarized text and the chunking model, the chunk text function which we just went over. So summarize text to summarize the document, chunk text function to chunk it into smaller pieces, ingest document function to send this data to our Chroma database for further retrieval. So this is essentially what it takes to develop a RAG based system where you input some documents and then you create a chatbot which can utilize the relevant chunks to answer the user's query. In order to run the Streamlit application, you need to first make sure that your environment is activated. Second, you need to type in the command Streamlit run and your file name. So our main invocation file was main.py. You'll see that this automatically opens in your browsers. Okay, so as mentioned, this is where we give our file as input. Once I click open, it will call the markdown library to convert this document into simple text. So here we have the output, we have the extracted text with us. Next, we have called the OpenAI LLM with Gemini 2.0 Flash to generate a summary. Now, as soon as the summary is generated, all of this document is converted into chunks and uploaded to our ChromaDB instance. Next, now our chatbot is ready to answer our queries. So let me demonstrate this once again. So you guys might know, right, that Trump and Musk recently got into a feud. So let's ask it about that. So as you can see, it has fetched the relevant context here based on our document, and based on that the chatbot has responded with accurate details of the document. Rather than hallucinating or saying that I don't know, it was actually able to answer on a news that was there just 24 hours ago. So this is how you can employ RAG retrieval systems to either update the knowledge of your LLM or make it answer your queries based on personal documents. Thank you.
my second year, this entire ChatGPT thing had just come up, and back then ChatGPT did not have image support. So I genuinely thought that maybe you could put that in as part of my BTech project or whatever. Those were naive days, but yeah. So that is how my journey started, and I worked at a company called Game Theory for around 6 months, and where we focused on visual analytics using sports videos. So that was a interesting learning. Then I joined BharatGen, and a little bit about BharatGen is that we build foundational models for India, and so basically training these foundation models like ChatGPT or DeepSeek or Qwen or all of these grades of models is extremely difficult because of the high level of engineering required. And those recipes, unfortunately, even though the model weights are public, the way how they made them, how they work the way they work, is still a mystery to us as a country. So BharatGen was inaugurated in order to understand that recipe and build models for India by India, focusing on Indian problems. So I've been working in the vision vertical, and so there are two projects that I've had the luxury of being part of. The first one is eVikray. So I'd like to motivate our discussion on VLMs by showing you a couple of demos, because let's face it, technical things are a little boring without a demo. So I'll just show you a couple of demos. So yeah. Okay, it's okay. Yeah. Got it.
खूबसूरती से तैयार की गई सोने की टोन वाली हनुमान देवता की मूर्ति जटिल रूप से विस्तृत और अलंकृत पैटर्न से सजी हुई।
Yeah, not really proud of his expressions, but yeah, you get the gist, right? So basically, the first model we developed was an e-cataloging model. So basically, we were focusing on the strata of India who had products that they wanted to sell, but they couldn't sell because they had a difficulty in actually uploading the descriptions of products and all. So this is actually a very important problem, because when you go to rural India, not a lot of people actually have the knowledge on how to type things in English, how to search engine optimize things, etc., etc. So this was a very, very important innovation from our end, and I'm grateful to say that it has reached the hands of many sellers across various rural stratas of India. So basically, the technology that powers something like this is something called a vision language model. And to motivate how vision language models work, I'll show you a small example. Can any of you maybe pick up the mic and tell me what exactly you see here? Arre. Yeah. Anyone? So do I have to give the mic to someone? Can we have a show of hands where somebody can explain to me what exactly is going on here in this image? If anyone is there?
Anyone would like to explain that? What do you think, like the first vision?
It's not a trick question, guys. It's a generic question. There's something comedy going here. Just tell me, what do you think it is? Yeah. Give her the mic. Yeah. Yeah. Please, someone. You're on it.
I think he's checking his weight, and his colleague or whoever is increasing
Obama.
his weight by putting it like.
Correct. Exactly. So, right. Um, there's this very interesting saying in computer vision, there's this calling called an image is worth 1,000 words. So basically there's so much going on in this image. There's Obama who is playing a prank, so you have to detect that this person is Obama, and he's stepping on that scale, so it's increasing the weight. The guy is confused. He doesn't know why his weight is too large. There's a mirror behind him. There are people laughing. There's so much complexity going on here. So this is one of the first images that people actually see during their computer vision course. And the holy grail of computer vision is trying to understand images like this. And this is a very big challenge. And in order to understand images like this, we have developed something called vision language models. So you guys are familiar with LLMs, right? I'm sure everybody uses ChatGPT from day to day. So these models work via text, text regurgitation or autoregressive decoding, more like it. So basically what we want to do is project this image into text space. So what I mean by project an image into text space is, if we could give some sort of description of this entire scene, what exactly is going on, what are the details of it, then a model should be able to understand this and then treat it like a set of treat it like language itself. So it should be no different from any other prompt that you give, right? So this understanding an image like this is the main challenge in computer vision. And yeah, so I'll just motivate. So now that the motivation is done, let's get into some technical details. Right. So before I get into what exactly a vision language model is, I'll try to preface by explaining what a image encoder is. So do you guys know about how a tokenizer works in language space? Are you guys familiar with basic NLP, what an embedding is? Yeah, lovely. Do you have a chalk or something? Yes. Oh, okay, lovely. Right. So basically, right. So an embedding in both CV and NLP. By CV I mean computer vision, and NLP is natural language processing. So in CV and NLP, a token basically means the compression of whatever is present. So basically, let's say there is a text or there's an image and you convert it into a single vector, an image, or let's say this is a good class, right? You convert this into an embedding, basically a vector. Your hope is that whatever content is inside this image can also be found within this embedding. So basically it's a compression of the world. An embedding basically means compressing the world. And in order to understand the interplay between text and image, for example, in the image I showed previously, if you give a description of the image like I gave, for example, Obama is pressing his foot on a weight machine and the weight is increasing as a result of him pushing down on the weight, and the person looks confused and all this. Let's say all of that information was listed down somewhere. My hope is that both this and this, the image and the description, have to match exactly. Does that make sense? So basically we want the image and the text to map to the exact same token, this exact same embedding. So in order to do this, what we traditionally do is, in LLMs we have a large corpus of pre-training data, right? Because the internet is filled with people and people keep writing on the internet no matter what you say. There's reviews, movie articles, everything in the world. So text naturally has a lot of pre-training corpus. They have a lot of data for which we don't need annotations. But images are not like that. Nowhere, in no place is there a ton of images and what exactly the image means and all that. So what the OpenAI people did back in 2019, it is actually quite genius and quite remarkable, is you've seen these, anytime you open a browser window and there's an image and the image doesn't render, usually there's a line of text called alt text. It's called alternative text. So basically if the image doesn't render, you want to show an alternative version of the image itself. So that part was actually developed by people in order to facilitate low bandwidth internet connections as well. So even if a person had lower internet connection, they still wanted the person to understand what was in the image. So basically what the OpenAI folks did is they basically collected all those image text pairs. They ran a scraper through the internet and they collected a bunch of these image text pairs. So naturally, let's say for example, take this for example. There is this image of a dog here and there is its corresponding caption, Pepper the Aussie pup, right? So you know that this image is going to be related to that text, that description, right? So basically they use this as the pre-training corpus for their first ever foundation model. So basically before this it was all GPT, BERT and all that, but after this actually spawned a new race towards a vision language model. They open sourced it, I don't know why, but anyway, good for us. So image, text, because you can't, matching these at the same time will not look good, you put an image encoder, typically a CNN. Yeah, CNNs we'll cover later, but just imagine it as a black box where if you put an image into a CNN, it will spit out its embedding and that embedding will be an approximation of the image itself, right? So this is text and you put it through something like GPT or BERT or whatever. Actually they use GPT-2 back in their paper. Actually this clip paper is extremely a good paper. Please read it if you guys have the time, right? It actually touches upon a lot of nuances. My entire cross entropy journey started from here. So it's a lovely, lovely paper, right? So, so basically image to CNN, text to GPT-2, and you basically want to make sure that this cross product is maximized. Dot product is maximized. So why exactly do we want the dot product to be maximized? So go back to 11th standard mathematics. Let's say two vectors are there. So who remembers the formula for the dot product? Let's say I have two vectors here, A and B. What is the formula for the dot product of these two vectors? AB cos theta, right? Exactly. Lovely crowdy laser. Anyway, if this theta is the angle between them. So let's say two vectors are very close in embedding space. Then if two vectors are very close in embedding space, then the angle between them will be low and as a result this cos theta will be very high, right? And if let's say the two vectors are opposite to each other, they have nothing in common, then the angle will be 180 degrees and this will be negative, right? So basically when you say two vectors are similar, you mean you try to maximize the cross product between them, right? So all of machine learning basically comes down to vector mathematics, whether it be LLM training, VLM training, regression, whatever. Everything comes down to very simple vector mathematics. So be clear with your basics, guys. But yeah, you guys answered very well. So this is what we want to maximize. So we want to maximize the angle between the two vectors. So as a result, if you maximize the dot product itself, then we are good, right? So basically what these clip people did is they chose a lot of these images and a lot of these alternate texts And what they did is they constructed a matrix like this. And they basically, for example, let's say the text 1 and the image 1 are two corresponding images. For example, Aussie the pup and this are two corresponding image text pairs. And let's say there's one more text pair called this is a very good class and your picture was there. That could be another text pair. So let's say you do a dot product of everything with everything, right? Are you guys following me till here? So logically speaking, what is the thing that you would like to maximize? You would like to maximize this part, right? I1 T1, I2 T2, I3 T3 and INTN, right? This is very important, guys. Please listen to this. This was a question asked to me in my IBM interview. So this will help a lot if you guys remember this. So the diagonal is what you want to maximize all the time. Is that clear? Does anyone have any doubt? Okay. So if you maximize this particular diagonal, then what happens is your image encoder learns what the mapping of this image is with which text pair. For example, it will know that this is more closer to Pepper the Aussie pup rather than this is a very good classroom, for obvious reasons. So because of this web scale data, see, LLMs, VLMs are extremely data hungry. So you'll have to figure out ways of how to leverage already pre-existing corpus in order to train them, because having an annotation team and having them annotate all the documents is going to be, first they'll game the system, and second is that it is extremely expensive and you can't get it done at scale, and the amount of diversity you have in your data should be extremely high. So this strategy was actually quite genius. There have been multiple papers since then, but CLIP still stands as one of the best vision encoders ever trained. So what happens is they'll use some sort of contrastive loss. So basically this entire method where you try to increase the similarity between two corresponding things and decrease the similarity across everything else is called contrastive training. I'll just give you another example. So basically, whenever anyone asks you about contrastive learning or contrastive methods of training, you always remember this picture. So basically, this and the thing that is above are actually a lot closer than this and this, right? For obvious reasons. So you try to maximize the similarity between the two embeddings, and you try to decrease the similarity between these two embeddings. So this is exactly what is there. You maximize this, you minimize that. The distance function is the opposite of similarity, right? So as distance function increases, your similarity decreases. So basically it's the opposite of whatever we did. So this is called contrastive learning, guys, right? And the full form of CLIP is contrastive language image pre-training. So basically it is a way to pre-train any vision encoder, whether it be a CNN or a VIT or a transformer or whatever, or a Mamba architecture or whatever. You try to decrease the space between language and image, and so basically that enables you to find out an embedding that is extremely close to whatever the image also means. So right now, are we clear that whatever embedding comes from an image after it's put through a CLIP model is going to be very close to text as well? Are we clear about that? Let's say I caption the image and I have that text and I have this. So both are going to be analogous. Are we clear on that? Both are going to be extremely similar. So right now the challenge is going to be, how do I use this as an input to my LLM? Because that is in image space, this is going to be in language space now, and whatever language is already there is anyways going to be in language space. So what we want to do is we want to align these two modalities and produce language after this. right? So I'll just go over how that works. Yeah. For example, let's say there's a image here. Is everybody able to see this screen? Yeah. So there's an image there. So there are two cats, and let's say there's this question: what is the breed of these cats? And I put this through a vision language model. It should be able to answer the cats in the image appear to be domestic short hair cats. I did not know that was a cat breed, but anyway, yeah, if it's telling it's right, it's probably right. So that is one thing. So it should be able to answer that. It should also be able to follow instructions. For example, you want to segment the striped cat. Basically, segmentation is where you, if you guys are familiar with Telugu, it's called diddadam. So basically, it's, you shade. When you are a little kid, you usually shade the portions that were actually a cat, right? Or you would like to cut it out. So that is called segmentation. And one is object localization. Is one cat behind the other? So, or one-shot learning with instructions. Striped cats are called tabby cats. What is the breed? So basically, you have an instruction here, and you want it to follow this instruction. So just like an LLM prompt, you want all of this to be done using the image. So basically, how is the vision language model constructed? What is the architecture of the vision language model is something that we'll look at. But is everyone clear of what an image model is supposed to do? A VLM, what is it supposed to do? It's clear, right? Yeah, I'll just wrap it up quickly. So, yeah. Right. So, so before I get into how a VLM works, I'll just give you a quick overview of how an LLM works, right? I know you guys know, but just to reiterate once. Let's say I consider GPT, okay? So basically what is going to happen is, let's say I give a prompt, what kind of cat is this, right? And I give the image, right? So basically what is going to happen is, the byte pair encoding tokenizer is going to break this up into multiple words, and it is into multiple tokens, and it is going to tokenize each one, and it is going to give me one token for each, right? And you basically push all of this through this model. Let's say the image was not there, then you'd push all of this through the model and you try to answer somehow. There are no cats in the image, I don't see any image, something like that. But now that you have this image, you want to convert this image also into tokens that can be ingestible by the LLM itself, right? So what you basically do is, you create a set of image caption pairs again. This is called pre-training for the LLM. So basically what is going to happen is, usually there is this entire autoregressive training, right? Till now, if you are clear with the clip, we have never done any sort of autoregressive training. So there is no autoregressive decoding anywhere in clip. It is just contrastive learning, right? So about the decoding part, let's say there is an image like this, and I break it up into multiple tokens via the clip model, via whatever model we've seen till now. We have the clip model, and we get one vector. I'm oversimplifying a little here, so don't answer the exact same thing in an interview. So be careful about that. This is just a little bit of an oversimplification. Okay, so I get it into one vector. So basically, if you guys were clear about clip, you would know that this vector is basically just the description of the image, but in a different space, right? Clear? So basically, this is the same as how, let's say, there instead of this image, I had a lot of text describing this image. this and this would look exactly the same. The embedding of both would match exactly to be very close to each other. So like I said, that dot product is going to be very less. So this is going to be an approximation of the image itself. And let's say I have another MLP layer on top of this, right? And I generate a series of vectors from this, and I push this through this. Then it is basically going to be like I broke this down into its corresponding tokens, which are basically textual tokens only. So basically it'll be like instead of this tokenization happening, it will be like I gave it the description and I tokenized the description. So it is no different from how an LLM would ingest this, right? So this and this is exactly the same. And once this is there, and if you've pre-trained accordingly, that is an entire completely different process. Maybe we'll go over that next week. So if you've done it correctly, then it will start to output whatever I have already mentioned. So basically, what kind of cat is this? This is the domestic cat. So this is a little hava mein, but next time we'll probably code this up. You'll be able to understand it a lot better. So basically, this is one of the first papers that came out in vision language modeling. This is called LAVA. Like llama, you replace the M with V. So it's a visual version of lava. So basically what happens is there's an image encoder, there's a projection layer, and there's a language instruction. This gets encoded on its own. This encoding happens via a projection layer, and everything gets pushed to a regular LLM. And there's a response out of it. Right. So basically what we did is this vision encoder acted as our bridge between image and language space, and once it was tokenized and once it was in a format that was ingestible, you can push it into an LLM and it will work exactly the same, right? So all of the magic that you see, the magic that you saw in that eVicry app, that was all basically this, right? So hopefully next week we'll be able to code it up. Any questions, anyone?
What does projection mean?
So basically you guys have a tokenizer here, right? So there's a tokenizer here, right? A tokenizer is basically just a lookup table. So instead of having a vanilla lookup table, you have it via an MLP. An MLP basically what it does is the projection is called an MLP, and that MLP adds some amount of nonlinearity, which makes it a little more robust than a traditional lookup table. Because of the nonlinearity, it can accommodate more features, and it is basically a way of tokenizing the outputs from the vision encoder, right? Anything else? That was a very good question. Anyone? So I take it you guys understood. Okay. So I'll send you guys a bunch of resources on how VLMs work. I hope you guys will be interested in this. So just to give you some context, 4 of my friends from my batch are in internships right now. One is in LinkedIn, one is in Sprinkler, and 2 people are in Adobe Research. All of them are working on VLMs. So it's an extremely hot field. Papers come left, right and center on this. You have to be extremely on your toes. But it's a very rewarding field, to be honest. And I hope a lot of you guys will look into this. They're getting paid really well actually. Not me, but them. But so I hope that all of you guys will also consider looking into VLMs. And if you guys have any other doubts, I'll be here. We can chat. My office is at Bharatjan. If you guys want to come anytime, drop in. Feel free to do so. And I hope I was not too boring. Yeah, thank you.
UI. And even Streamlit is as good as any rich UI.
ऑन कर वो नहीं है सिंगल प्रेस ये भी चाहिए ना
So Streamlit is as good as backend application. With the backend application, we need some front end. Or front end ఏమన్నా ఎక్కువ? React, HTML, CSS, basic HTML, CSS, user ID, password అని ప్రతి దానికి ఉంటుంది కదా. సో అలా do you wait till that front end is built? So we have some back end operations చేస్తాం మనం, like the front end కానీ stubs అంటాం మనం వాటిని. సో అలా యూస్ చేసుకొని చేస్తాం. అలా కాకుండా we have some, how about like having a beautiful UI within a few commands of code. ఏదైనా రెడీగా ఉంటే మనకి we have some front end where with a few lines of code we can get it done, where we have the interaction with the back end. So simple, like this is the package that we will be using it, Streamlit as ST. So ఈ Streamlit package ఏం చేస్తుందంటే it will give the ready-made frame, ready-made buttons, ready-made lot of other controls where it can interact easily with the back end. సో అలాంటి వాటికి మనం ఉంటే మనం దెన్ we need not concentrate on the building the actual buttons, right? So that is what the Streamlit does. So Streamlit is basically a simple UI building package, especially for Python. So you can create as beautiful as the controls that you see here. So అది ఎలా బిల్డ్ చేస్తాము, how to build a simple UI and how to host it and how the interaction happens, one of our Swecha volunteer will go through it. Okay? Yeah. Ready?
अब उसके बाद उसको एक्सपेंड कर.
Okay guys, so if you want to know about the Streamlit, just go to streamlit.io. So if you want to deploy your first Streamlit app, you can use the already there. So Gallery has many of the already built apps which you can clone it and deploy it. For example, we have a lot of things like extras, roadmap, all basic stuff to LLMs, Snowflake powered, NLP and language. You can just start your Streamlit through this, and as Rajan has said, you have to build a Streamlit app with a publicly available data. So first do that. Who are not yet done with any one of the Streamlit apps? Okay, you have time now. You can build your Streamlit app and make it ready. If any doubts, there are people who have already built it. You can ask them. You even have documentation for this. Everything is available in the streamlit.io.
ब्लैंक पेपर लगा दे, ब्लैंक लगा.
Everyone downloaded that Streamlit package? We've installed? Done, right? So go to any of your coding copilots or Visual Studio. You can download a small program